Okay. Okay.
So see on this slide, the following noise exposure were
Okay.
recorded. 92 dBA for 3 hours,
Okay.
95 dBA for 3 hours, and 90 dBA for 2 hours. So
Okay.
imagine the supervisor walks across
Okay.
this noise source for this many time period, and they are asking what is the total
Okay.
exposure for an employee. So in order to identify it,
Okay.
okay, we have this formula, time weighted average, which is nothing
Okay.
but the concentration of noise level multiplied by the
Okay.
time they have
The
exposed
hours.
for a
Okay.
particular noise level.
Okay. Okay. Okay.
It can be n number of noise, okay, and
Okay.
just divide that
Okay.
one by the total time period the particular employee exposed for the noise. So
Okay.
here the calculation becomes 92 multiplied 3 plus 95
Okay.
multiplied 3 plus
3.
9.
Okay. Then 90 multiplied by 2 and divided by 3 plus 3 plus 2.
Exactly.
Okay.
So
The answer will become 93.
exactly it will be 93.
Mm.
See the second question. A sound absorption coefficient of zero point 0.6 means that
Okay.
blank of the sound energy in a wave would be reflected. So one of the engineering control for noise is to keep the sound absorption material, which we technically call sound
Yes.
attenuation. So
Okay.
we choose those material to absorb noise, we have to see the technical data about the noise absorption coefficient value for the particular material. Normally, it
Okay.
varies from 0 to 1. What this 0
Okay.
represents and what this 1 represents. 0 means 100% will be reflected. 1
Okay.
means 100% will be absorbed. So here
Okay.
we have given zero point 0.6. So what it means for 60% of the noise will be
Sir,
absorbed.
sir, your voice will be distracting. There is some disconnecting your voice.
Really.
Yes.
Is it okay now?
Now it is okay.
Okay, good. So whenever you have interruption, just to stop me there so that we will correct and we will continue. So as I
Okay. Can you tell one more thing about the 0 and 1?
yeah, 0 means 100% is reflected. Okay.
Okay.
100 means, sorry, 1 means 100% will be absorbed. Here in the
Yes.
question,
Correct.
they are meaning zero point 0.6. So what is the meaning behind
Oh,
this? 60% of the noise will
oh,
be absorbed and 40% will be
yes.
reflected. So what will be the
Reflected. Correct. Reflected means A. Answer A is the 40% reflected.
yes. See, what is the permissible noise exposure in duration per hour of 97
Okay.
dBA exposure? For
7.
example, take the
Okay.
question in a practical way. We know the safe level for noise in USA or as per OSHA, it is 90 dBA, right?
Yes. 90 dBA.
But
Yes.
the particular noise source is producing 97 dBA. Imagine there is a machine operator who needs to
Yes.
continuously operate this machine. So
Yes.
there is no option to reduce the noise generated from the machine. So the management are choosing
Okay.
to rotate the job between the machine operators. So how many hours
Okay.
we can expose safely, that we need to identify.
Okay.
So
Yes.
from the formula sheet, there is a formula here represented and it is also in the formula sheet. So 8 divided
Okay.
2 to the power L minus
Okay.
90 divided by 5. So in the place of L, you can substitute this 97 and
Okay.
the how.
Minus 90. That means it's 1.4. 2 raised to 1.4 it will come. So uh, we can 2.64. 8 divided by 2.64 equal to 3.03. That means 3 hours. Option B.
So he can continuously work for 3 hours, not for the 8 hours job. So after 3 hours, you need to rotate another machine operator.
Yes, okay, okay.
Okay. Next question. In a work area, the noise level are 95 dBA for 2 hours, 90 dBA for 4 hours, and 85 dBA for 2 hours. Does this exceed the
Okay,
allowable limit or not? That's the question.
okay, okay,
In this question, we will use dose formula. Why we are not using time
okay,
weighted average formula? Because it gives the value,
okay,
okay, but dose gives the condition. Here,
okay,
they are asking the condition whether it is increased or decreased.
okay,
What we do first, we apply all this noise level in the safe time limit for the particular noise. We will
okay,
identify for 95 how much,
okay,
for 90 how much, and for
okay,
85 how much it's coming.
hmm,
Okay. So if you substitute
okay,
for
okay,
95, it will be 4 hours, and for 90 it will be 8 hours, and for
okay.
85 it will be 6.
8 hours. Okay. 16 hours.
Yeah. So here now we will move to next step using dose formula, which is
Okay,
100 multiplied summation of C by T. What is
okay,
C representing is how much hours you have exactly exposed to the particular noise. So for 95 is exposing for 2 hours, right? So 2
okay.
divided by what we received for 95, it is
That
4.
is a 4.
So 2 divided by 4 plus 4 divided by 8 plus 2 divided by 16.
Okay,
Answer.
okay.
So
8, then 85 means 4 by 16. 100 into.
now again I will repeat, it will be 2 by 4, 4 by 8 and 2 by 16. So if you do the math, you will end up with 1.125 inside the bracket.
Mm,
So multiply
yes, yes.
100, it will be
Okay.
112.5 percentage. Am I right?
112. I didn't multiply that one, but I was writing that
Yeah.
everything. 25.
So note down this condition. Whenever the dose
Nice.
goes more than 100%, it's not
Okay.
limit. Okay.
Okay, okay. It is exceeding the limit.
Yes, it is mentioning
Okay.
it have exceeded the limits. If it
Okay.
more than 100, it should be less than 100.
Okay. 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 That means the answer is A.
Yes. Apply the same concept for this question and let me know the
Okay.
answer.
Oh, okay.
Here also they are asking, was the permissible noise exposure exceeded? So they are asking the condition, not the value. So we will go with dose formula.
Okay. Okay. The condition we are already okay. Then D equal to 100 divided uh, 10. So 110. So each I want to find out that T.
Yeah, for that I will help you.
Okay. For 110, can you tell that in 110? I think half quarter. No, half.
It will be half an hour, and for 90 it will
Okay.
be 8 hours.
And then 90 is 8 hours. 80 it
Yeah.
will become 32.
Yes.
85 it will become 16.
Yes.
So it will come. C equal to measured value divided by measured 0.5.
So what value you are receiving?
I just mentioned that one. 3 by 2 plus 2.5 by 16. I didn't calculate that one. That's the first one is 100 into 0.5 divided by 0.5 plus 2 by 8 plus 3 by 32 plus 2 by 2.5 by 16.
Exactly. Altogether,
Okay, then
you will end up with 1.496.
496.
Okay, if you do the math, you will end up with
So that means a yes
1.496.
over the limit by 50%. That means option C.
Yes, exactly. See, many people will get confused whether it will be option B or C. So in order to
Okay,
conclude that, we need to do the math and we need to know the value. Then only we can
okay,
choose the right option.
okay.
Okay. So here we will discuss about reliability and the
Okay,
formula, what is represented here, it's in the formula sheet. So what is the reliability? Is the ability of a system to perform its required function uh, under stated condition for a specific period. It is often
okay,
reported as a probability. To calculate the reliability of a compound, use the following equation. See, basically, reliability means success, probability of
okay,
success. Okay,
okay,
for an example, each component inside the plant will have the reliability value.
okay,
Based on that, reliability team will fix what time period this equipment need to be maintained or need to be
uh,
inspected. So all these
okay,
criteria will be determined from this value only. Okay.
okay,
So here reliability formula is the second formula. R in bracket T
okay,
is equal to e to the
okay,
power minus lambda T. What is lambda? It is nothing but failure rate.
okay,
Okay, lambda is nothing but failure rate and T is for time period. See
okay,
here, there is an example for us. An inline valve has a failure rate of this much value. What is its reliability in an operation period of 5,000 hours? So it's having a failure rate and it's having a continuous operation. So directly apply on the
formula,
formula,
okay,
you will end up with the value. So reliability is almost 100%.
okay, sure,
Okay. So it is
okay,
going to run continuously for 5,000 hours. The probability is 100%. If the probability is less, then they will go with some other options to have
okay,
a backup for this valve or some other scenario they will go. Okay. Next one, reliabilities are connected in two connections. One is series connection and another one is parallel connection.
okay,
For series, it is a multiplication of R1, R2, and it goes on. So this is the basic formula for series reliability
okay,
connection. See the question, you will understand. You are asked to calculate the reliability of a system with the 6 individual components. The reliability of each individual component is the values they have given. What is the system reliability? So they have given total 6 and
okay,
they are asking the overall reliability. So
okay.
we do use the
Multiplication of
formula
all,
directly, okay, in order to identify the overall reliability of the system.
okay,
See here, If the systems are connected in series connection, the reliability will be, the output will be less. See here,
Okay.
each individual component is having almost 98%. But if we are connecting
Okay.
in series connection, the overall
Okay.
reliability is getting decreased. Now let us see
Okay.
about parallel reliability connection. Okay. See the example. Given the sample data provided in the series example, calculate the system reliability of a six component acting as a parallel system. They use the same question,
Okay.
but they are
Okay.
just altering the connection.
Okay.
They are
Okay.
doing in
Okay.
parallel connection. So we will utilize this
Okay.
formula. Then you see the output. It's almost 100%.
Okay. Okay.
So by seeing the value
That means
itself, it is
increasing.
well understood. The reliability will be high for parallel connection, and for series connection, the reliability will be less.
Low.
And I
Okay.
request you to note down this formula,
Okay.
okay, for series
Okay.
and as well as for parallel.
Parallel. Okay. Can you put the second slide parallel? Yes. Okay.
Okay, let us see some practical question. Two walls are placed in parallel on a tank. Wall A as a failure rate and wall B as a failure rate of this match. The likelihood of both devices failing simultaneously. Here they are not asking the reliability, they are asking the probability, right?
Okay.
And they have given
Yes.
the failure rate. So just have a note.
Okay.
Series, okay, put a heading probability.
Okay.
Under that, series in
Okay.
bracket, keep or gate.
Keep.
In bracket, keep or gate. Mention or gate,
Okay.
or gate.
Okay. Okay.
And next one, parallel,
Okay.
in bracket, keep and gate.
Okay.
So here they have not mentioned either series or, okay, they have mentioned parallel.
Parallel. Yes.
So what we need to do? Okay, I didn't mention the condition. Series you have mentioned now, in bracket you mentioned OR gate, right?
Yeah. Yes.
Okay, next mention addition.
Okay.
In parallel, in bracket you have mentioned AND gate. After that, mention multiply. This is the condition.
Can you tell again?
Series is for addition, parallel is for multiplication.
Parallel for multiplication. Okay.
So what we need to do here, we need to multiply the failure rates.
Yes.
So we will end up with option C. The overall failure rate will be very less.
Oh, okay.
Okay. Why it is
Okay.
very
Okay.
less?
Because
Because it is in parallel connection. The
parallel
success
connection.
rate will be always high.
Yes.
Okay. See the second question. A wall system has the following wall component failure rate. V1 is having 4 subsystems.
Okay.
The fault tree of the wall system indicates that wall subsystem SS1 contains series component and wall component X4 and SS1 are parallel. what is the anticipated failure rate of V1? So altogether, what is the failure rate they are asking? We'll go step by step.
Mhm.
See,
Okay,
first
yes.
SS1, all are connected in series.
Yes.
So what we need to do if it is in series?
It's uh it's addition.
So zero point 0.4 plus 0.1 plus 0.2 will be 0.7.
Yes.
So we identify the value for SS1 and SS1
Yes.
and X4 are in parallel. So what we need to
Parallel.
do?
Multiplied by
Yeah, so zero point 0.7 multiplied 0.5, we will get
equal to
0.35. Am I right?
3 5. Yes.
So the
Yes.
overall failure rate for the wall will be 0.35.
Okay.
In a series reliability model, all components must work. The system reliability is a function of all component reliability. The appropriate equation to represent series reliability, as we discussed before, okay, it will be option
Oh,
B to represent series because other options are not close to the conditions
okay.
for series reliability.
Okay.
So we will go
Okay.
with
Series condition
option
means
B.
it's okay. Okay.
See here, a door hinge fails 4 times out of 1 million operations. What is the failure rate?
Okay.
Write down the formula. Failure rate is equal to number of failure rate is equal to number of failure divided by total number
Okay.
of operations. Okay.
Operations.
And the next,
Okay.
um, write down another formula for success rate is equal to number of success,
Success rate equal to
number of
number of
success
success
divided by total number of operation
divided by total number of.
operations.
Okay.
You can use this formula
Yes.
or else you can use this formula also.
Okay.
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 Probability of failure plus probability of success is equal to 1. So if we know at least one side,
Okay.
then you can identify the success factor.
Then other five automatically get it.
Yes.
Okay. 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 Okay.
So apply the formula for this question and let me know the option.
Okay. Okay. So,
It will be 4 divided by 1 million.
okay. That means a
It
4 times out of. Okay.
will be option C.
See. Yes.
So what will be the value for the right hand side question? It fails 4 times out of 1 million operation, but they are asking success rate.
Success rate means one
So
minus.
yeah, you can do that, or else
Okay.
identify the success rate or number of
Okay.
success. 9
Okay.
lakh 99,996 is the number of success divided
Okay.
by 1 million. Am I right?
Yes.
Then you will end up with your answer.
Okay.
It will be option A.
Yeah.
What will be the value for the last question here? They have given the failure rate and they are asking the overall failure rate for the system
Overall failure.
and they have
Okay.
mentioned series. So
See.
this
So
means,
we can add that. It's a
yeah,
addition.
just add these values, you will end up with the
Okay.
option.
Okay. Okay.
No issue, you can do the math after some time. Only thing is we
Okay.
need to know the concept.
Yes.
See this question. How much acetone would have to be evaporated into a room which is having a volume of this much, length, width, and height, to give a final concentration of 10 ppm at STP. What is STP? It's not a sewage treatment plant. It's standard
Okay.
temperature and
So
pressure.
temperature, pressure.
Okay. Specific gravity they have given, and molecular weight of acetone they have given.
Hmm.
And this formula is available in our formula sheet. I will show you that.
Okay.
Can you see my formula sheet?
Yes.
So here it is. Under concentration of vapors and gases, this formula will be there. So it is basically used to convert ppm to milligram per meter cube.
Yes.
Let us go back. So see here in the option, all are in ml. So now how we are going to end up with the option. Let us see the workout
Okay.
step. They have identified
I
feet
guess.
cube.
Yes.
Then,
That means the volume. First they identified volume.
yes, it's in feet cube. But in the formula we
Okay.
have meter cube. So they have converted
Okay.
feet cube to meter cube.
Okay.
So to do that, we need to divide the value by 35.3. If you are
0.3. Yes.
not having that previous note, you can note down this value.
Yes.
Okay. Next, what they are doing, they keeping milligram per meter cube on the right hand side and taking all the values to left hand side, because
Left hand.
ppm value is given 10, molecular weight value is given, and
Okay.
24.45 is constant in the formula.
It's a constant value.
Then they can easily identify how many milligram per meter cube it is. Then they
Okay.
are multiplying with room volume.
51.
So
Okay.
meter cube and meter cube will get cancelled. You will end up with milligram.
Okay.
They
Yes.
are converting the milligram to grams.
No. Okay. Okay.
Okay. Then
Mhm.
they are taking the specific gravity value. So here it is gram
Okay.
for gram per milliliter is the unit for specific gravity. Okay.
Okay.
So what they
Okay.
do, they just divide the value by specific gravity. Gram and gram get cancelled.
Okay.
So milliliter will come to the top.
Cancel this.
So that is the value we are ending up.
Okay.
You got the concept?
Okay. Okay.
Apply the same
Yes.
concept for second question and let me know the answer.
Oh,
The same
okay.
workout, apply for this question
Mhm.
and give
Okay.
me the answer. You should get option C.
Okay. Into 4 equal to 26.24. Yes, option C, 33.2.
Okay. See here, what would be the TLV of a mixture containing 35% by weight methyl chloroform and TLV value they have given, and 35% chloroform TLV value they have given, and 30% petfluoroethylene and TLV value they have given. So where
Okay.
this formula comes from, again go to the same section, you can see the formula here. Okay,
Okay.
so
That's for the
here,
mixer. TLV value for the mixer.
exactly. So F represents the fraction value. How much percentage? Just
Okay.
convert that one to decimal, then you can
Okay.
substitute on the formula. So from the question, they have given in percentage. So if you want to convert this one to decimal,
Point
what you
35.
exactly you divide this
Point
one
three
by
five.
100. So 0.35
Yes.
divided by 1900,
1900. Then point three
0.35
five divided
divided
by
by,
divided by 50,
yes,
and
plus,
point 3 divided by 170.
yeah. So if you do the math, you will end up with the option. Okay.
Okay.
And
That's
for LFL, for the mixture, they have given the same formula for
okay.
UFL also. Okay, instead of LFL,
Okay.
they just substitute UFL. Don't look for UFL
Okay.
formula separately.
Okay.
Second question regarding ventilation. Assuming perfect mixing of dilution air with contaminated air, how long will it take to dilute 500 ppm of contaminant to 1 ppm? Assuming a dilution rate of 230 CFM. What is CFM?
Okay.
Now I'm asking what is CFM? It is nothing but
CFM is
cubic,
cubic feet per minute.
yeah, cubic feet per minute. What is CFS?
Cubic feet per second. Cubic
Okay,
feet second.
exactly. And a room size, they have given the volume. So they
Okay.
just want to reduce the concentration, and they are having a fan which is producing this much CFM, and the room volume is
Okay.
this much. So the conditions they have
Okay.
given, what they want and what they are having. So they are
Okay.
asking for how much time it may take. So for this,
Okay.
go to our ventilation section on the formula sheet. You can identify this
Okay.
formula. Okay, ln is nothing but ln, it is not log.
Okay.
Many people get
Okay.
confused. In your calculator, there will be log and ln.
Yes. Ln and log. Log.
Exactly. C1 is the initial concentration. What is the initial concentration
Okay.
from the question?
Here is it is a 500 ppm.
So C2, they require 1
It's a
ppm, which is
five
final
one
concentration.
ppm.
So
Yes.
Q will be 230 CFM.
That is the VFM. Okay. And V is the volume.
Volume, yeah. So we need to
Okay.
identify time.
Time. Okay.
Okay, change in time, but you just keep
Okay.
time for this
Okay.
question. Then
Okay.
keep the time in right hand side, move all the things to left hand side. You can end up with the option.
Okay.
Okay.
Okay. So means ln C2 divided by C1 into V divided by Q. There is a minus symbol is there?
Yes, so it just become addition. If it goes to
Okay.
right. Oh. So you will end up with option D.
Option D. Okay.
I'm moving on to third question. For first question also, if you do the math, you will end up with option B.
Yes.
Okay. So here we need to note down one condition. 1% is equal to 10,000 ppm.
Okay.
Okay, this is a sort of unit conversion. 1% is equal to 10,000 ppm.
Okay.
So for 10%, how much will be the ppm?
10% means 100,000.
Exactly. See here, pretty interesting question. A cigarette contains 6 mg of tar. Calculate the cumulative daily dose of tar received by 160-pound adult male who smokes 2 packs per day and each pack contains 20 cigarettes. So altogether he is smoking 40 cigarettes per day.
20.
Am I right?
Yes.
So each cigarette is
Yes, correct.
containing 6 mg. So 40
Yes.
cigarette will contain how much mg? 40 multiplied 6.
240, 240
240
mg.
mg. But see the question,
Yes.
mg divided by kg, body weight per day. So
Okay.
we need to convert 160 to kg. Divide this one by
Yes.
2.2. 1 kg is
Yes.
equal to 2.2 pounds.
2.28. Yes.
So what value you receive?
So 160 divided by 2.2. It will become 160 divided by 2.2. It will come 72.72. 72.
So 240,
72.73.
okay. 240 divided by 72.73 will give you the answer.
Yes.
Okay.
Yes.
It will be option B.
77.3. It will become 3.3.
Yes, it will be option 3.
Yes. Yes.
Next question. The following air samples are acquired. For ethyl ether, ethyl acetone and diethyl ketone, they have taken some air sample and
Okay.
the time weighted average. So normally time weighted average, it's for 8 hours. Huh?
Okay.
Now they are asking is the threshold limit exceeded or not. For this, note on the formula.
Okay.
It's nothing but summation of, sorry, my writing is not good on the system.
No problem.
C, C by T should be less than 1. This is
Okay.
summation. Huh? Summation
Oh,
of C by
okay.
T should be less than 1.
Okay.
So this is the condition we will apply on the question. What is C? It is nothing but concentration. And T is nothing but time
Okay.
weighted average. So
Okay.
425 divided by 400 plus
By 200.
400 divided by 400
400 divided by 400.
plus
Okay.
150
Then
divided by 200.
120 divided by 200.
So
Yes.
obviously it will be more than 1. I think
More
it
than
is
1.
2.81. Are you getting 2.81?
I just add the thing. Let's say 150 divided by 200. 2.81.
So it is more than 1, right? So obviously it is
Yes.
exceeding.
Yes.
Option will be
Okay.
A. Okay. Before going on to this slide, how much oxygen is present in air?
There is 21 percentage.
Okay. If we speak in fraction, it is 20.9.
20.9. Yes.
No, sure. So here what they tell, if a vessel contains 80% air and 20% hydrocarbon, what is the oxygen content of the vessel? So for
Okay.
100% air, it is 20.9%.
21%. 20.7. So, okay.
So for 80%, how much it will be? That is the question.
Okay.
It will be 16.8%.
16.8 percentage.
Okay, good. Next one, how many moles are in 60 gram of chlorine gas and molecular weight
Yes.
70.9? What is mole? Mass by molecular weight. So mass they have
Molecular.
given,
Yes.
molecular weight they have given. Just divide, use the
Okay.
formula. You will end up with option A.
Okay. Okay. Okay.
Next one, how many molecules does zero point 0.8 mole of chlorine gas contains if the molecular weight is 70.9?
The
So
same formula. No?
no, okay, apply the
How
formula.
many molecules?
So apply the formula.
There is.
Mole they have given 0.8 is
Okay.
equal to
Okay.
mass divided by molecular weight.
Molecular weight. Yes.
So multiply 0.8 with 70.9.
Yes.
Okay, you will identify the mass. Now we need to
Yes.
identify the molecules, how much molecule will be present on that
Molecules.
particular mass. For that, you need
Okay.
to go to our formula sheet to know the Avogadro value.
Okay. 6.23 into 10 raised to 23.
Exactly. So multiply with this value,
Okay.
you will get the answer.
Okay. Okay. Okay.
I think we are doing it wrong. Why?
Okay.
Write a note actually. Avogadro number
Okay.
is equal to 6.024 10 to the power 23. Unit is molecule per mole.
Unit is gram per mole. Gram and
No, no,
23.
no, 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 no. Not on my unit. It is molecule
Okay.
per mole.
Molecule per mole.
Yeah.
Okay.
So from the question, we have mole, right? So if we
Yes.
multiply both, what happens? Multiply mole with Avogadro number, mole and mole will get cancelled. We will end up with
Then
molecules.
it will get a molecule. Okay. Okay. Okay.
Yeah. So there won't be any use of molecular weight here.
Okay.
If you do that, you will end up with option D.
Okay.
Okay. See here, now we are going to see some electrical concept, electrical safety,
Okay.
mathematical sums.
Okay.
Uh, the formula represented on left hand side are given in our formula sheet.
Okay.
Okay, the chart I have taken from some of the resource where you can also remember these formulas, which will be helpful.
Mm, okay.
Now let us see.
This is your. I think that is chart you are not provided.
No, it will be on this slide. It is not in the
It is
formula
not.
sheet. Okay, and the formula
Okay. Okay.
provided in the formula sheet is for DC circuit,
Okay.
and for AC circuit the calculation get differed little bit. See
Okay.
here, to calculate the voltage of AC circuit they use this formula,
Okay.
but for DC circuit we know Ohm's law, P is equal to IR.
Okay. Yes.
This
Yes.
is for DC circuit. For AC circuit
Okay.
it is nothing but
Uh-huh.
root
Okay.
square power
Divided by
impedance divided by
into
cos pi.
cos the. Okay.
See the question here. Calculate the voltage for a circuit that is
500
5000
watt.
watts with
5000
a
watts with the
resistance. See
resistance with.
here again I am noting a condition here for AC circuit. Resistance is considered to be impedance.
Okay.
Okay, remember this. And the value they have given and angle they have given, and here they are not representing whether it's AC circuit or DC circuit. So if that's the case,
Okay.
go with AC circuit.
Okay.
Okay, because they have given angle of lag also, because in DC
Okay.
circuit there is no formula representing angle, but in AC
Okay.
circuit it will represent the
Mm,
angle. So we can
okay.
use the formula directly, then we can end up with the voltage value.
Okay.
See here, for power, they go with this formula. Again, they see for resistance, they consider impedance.
Okay.
Okay. And for resistance in AC circuit, they go with voltage by current.
Voltage and
Always remember, in AC
okay.
circuit, the resistance will be represented as impedance.
Impedance. Okay.
Yeah. See the question now. Three electrical devices are connected in parallel to 120 volt circuit. Device 1 has a resistance of 80 ohm, device 2 has a resistance of 150 ohm, and device 3 has a resistance of 240 ohm. What is the total current flowing in the circuit? Before going to the option, confirm me which one is series and which one is parallel on the picture.
First one is series, second one is parallel.
Good, good. So here we need to identify the total current. But we have three
Current, yes.
resistors which are connected in parallel. So we go with
Parallel.
this option. Okay, we go with
Okay.
this option to identify the parallel resistance value.
Okay.
Then we go with
Voltage equal
V
to
is equal
I
to
into R.
IR. So keep
Yeah.
I on right hand side, move R to left hand side. So voltage 120.
So V by R.
Yes, yes. So
Divided by
one,
R.
yeah. So you will end up with option B. Okay.
Okay. Okay.
The second question, what is the power rating of an electrical motor which draws a current of 3 amps at 40 ohm? Resistance value they have given, current value they have given, they are
40.
asking power.
Mm,
From the data in the question, we can't go
okay.
with this formula
We
because
did.
voltage value is missing. What I do, I bring the voltage formula over here. So this
Okay.
formula will become I square R. Am I right?
Okay.
Are you getting why it's
Uh,
becoming I square R?
yes. Yes.
Because I'm bringing voltage formula here.
I
So
square.
I
Ah,
know
yes.
I
That means the V, yes, V is up.
yes, exactly. V formula I'm substituting here because I don't have any voltage from the question.
Yes.
I have current and I have resistance, so
Yes.
I'm converting
Yes.
the formula accordingly. Then we can directly substitute the values on the question.
Yes.
Then you can end up with option C.
And
Okay.
yes.
And note down this formula for power. Force into distance by time. And let me know the answer for this question.
Okay. Determine the power watts a motor used for to operate a hoist which is used in equivalent to 200 rate of energy within 10 seconds.
In our first session, I told one unit conversion, right? Feet pound per second
Yes,
equal to
there
how
is a
many watts or how many horsepower I have told you.
yes one
So you might be using that
yes
conversion here.
yes that means the 550 lbs per second. No?
550 feet lbs per second.
Okay, okay. So initially we want to find out with the lbs and finally we want to convert that to unit na, in watts.
Yes. Yes.
So equal to power equal to 200 lbs into 55 feet divided by 10 seconds. 110 lbs feet per second. So 550 LES feet per second equal to 746 watts. So into 100 into 149.2. One digit is missing. Actually, 746. Actually, 1641. So 1492, the option D.
Yes.
But
Good.
there is a lot of variation is showing that one. Actually, I got the answer is 1641.
Now, I will explain you. First, how much feet pound per second will you say? 100 and
1210.
no, it should be 1100. 200
200
multiply
lbs, no?
55. Yeah,
Two.
200 multiply
Yes.
50, 55 divided by 10.
Okay.
What
Equal
value
to
will you
divide by
see?
10. Equal to. Okay. 1100 it will come. Yes. Right.
Okay.
Yes. That's correct. Then multiplied by 746 equal to divided by 550.
Don't
Equal
get
to
the
okay,
exact value.
1492. Correct.
Okay.
1492. Yes.
See this. If log 27x is equal to 2.38, x equals how much? So if we are multiplying log, what happens? It becomes addition. So if we multiply log inside 27x, log 27 plus log x is equal to
Log x. Yes.
2.38. Then you can
38.
identify x value. So take log 27 value from your calculator.
Okay.
It will be 1.431. Okay. Subtract it from,
Okay. Log 27x means log 27 plus log x.
yes.
Log x equal to 2.38 divided by
Why it is divided by?
log 20. Minus log 27.
Yeah. So take the value of log
Okay.
27. It is 1.431.
Okay. So 2.38 minus 1.31.
Yeah. 1.431.
Okay.
1
0.
point, not 31, 1.431.
Yes. The
So
answer
log
then
x,
it will become 0.949.
yeah, it is
So
log
log
x.
x is equal to point in. Yes. So x
But
is equal to.
antilog of 0.949. What is antilog? It is nothing but 10 to the power 0.949, which is nothing
Okay.
but 8.9. So if we round it up, it is 9. X value will be 9.
Okay.
Okay. You should know this conversion. What is antilog, what is log, and how to multiply log inside. These are basics, but
Oh,
you
okay.
can expect
So the
these
answer
things
will
in
become A,
your
na?
questions. Yes.
Okay.
A gamma radiation source reads 500 milliroentgen per hour at a distance of 1 meter. How far away must a worker be so the level does not exceed 25 milliroentgen per hour? First, go to our formula sheet
Okay.
and go to radiation section. And there is
Okay.
a column for ionizing radiation and non-ionizing radiation formulas. Most probably, the
Mhm.
questions will be framed from ionizing
Radiation.
radiation formulas. So, this is
Okay.
the first formula we are going to use now. Intensity,
Okay.
okay, of
Okay.
final intensity, initial distance by final distance.
And the final decision.
Or else you can take I2 by I1 is equal to D1 square by D2 square.
D2 square.
So they have used the same formula, apply the same inside the formula,
Okay.
you will end up with
Mm,
option B.
okay.
Okay. Now note down the formula, intensity
Okay.
of elimination is equal to, note down the formula, intensity of elimination is
Okay.
equal to candle power
Okay.
divided by distance square.
Distance square. Okay.
So apply the same formula for the last question on this slide.
Okay. Mhm. So direct apply. The Marish applying directly, na?
Yes, you will end up with
Go-
1000 divided by
Going to
400. It will be
yes.
2.5
Mhm.
foot candle.
Okay.
Okay. Now we will see how to use the psychometric chart. What is the moisture content of air on a day when the dry bulb temperature is 80 degree Fahrenheit and the relative humidity is 70 percentage? Just match the values on the psychometric chart. The below horizontal
Okay.
one is for dry bulb temperature and the arc on the graph is for relative humidity. So in the question they have given 80 degree Fahrenheit and 70% relative humidity. Okay,
Okay.
see here it is 60, it is 80, so the middle curve will be for 70. So match the value
70.
and identify the option.
Okay.
This is pretty old psychometric chart. If you see our formula sheet, there is an upgraded version of our psychometric chart. Okay, here see
Yes.
they have clearly mentioned dry bulb, wet bulb, the curve, what it
Okay.
represents, they have clearly mentioned it here. Okay. Can you see this slide now?
Yes.
See the question here. A worker is performing a moderate task with 75% work and 25% rest each hour. A task is performed indoor with no solar load on a day when a natural wet bulb temperature is 22 degrees Celsius and globe temperature is 27 degrees Celsius. Determine whether this worker is exposed to excessive heat or not. So they are asking a condition. So before
Okay.
that we need to identify WBGT value. Go back
Okay.
to our formula sheet. Here they clearly mention there is no solar load. So we will go with
Okay.
first formula.
Okay.
If it is a solar load, we need to go with second formula. And wet
Okay.
bulb value they have given and globe temperature value they have given.
Okay.
So directly use the formula to identify W being GT value. After identifying this value, this table will be provided if these type of questions are asked.
Okay.
It's from uh, source, but a BCSP will provide this. See
Okay.
here in the question, it is moderate task, which is having 75% work and 25% rest. So what should be
Yes.
the limit? Maximum limit? It should be 28.
It in
What
28,
value we receive? It is 23.5.
23.5.
So obviously it is safe. He is not exposed to
Yes.
excessive heat. Am I right?
So why the heavy type of work heavy more? It is mentioned that 25% work, 75% work and 25% rest.
Yeah.
And
Based on the
okay.
task.
Already it is mentioned that one in the question itself. It is mentioned that one there is a moderate.
Yes. And as well as
So
they
that's why
mentioned
we are
the
looking
condition.
only. Yes. So
Exactly.
that we are looking only that particular. Yes. 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 Yes.
Exactly.
I got it.
Exactly.
Okay.
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 Before we move on with next
So within.
slide, we yeah, tell me something you were asking.
Yeah, that means that this is the maximum limit is the 28. So we are within limit. That means it is safe.
Yes, so we can tell he is
Uh,
not exposed to excessive heat. He is in safe level.
yes, 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 correct, correct,
Okay.
correct.
Okay. So let us have a short break. After 10 minutes, we will
Okay.
continue the session. Okay.
Yeah, sure, 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 sure.
Shall we continue?
Hello?
Yeah, shall we continue?
Yeah, we can continue, sir.
Okay. Note down this formula,
Okay.
these two formula. I will explain the terms and note down
Okay.
that as well. This Ya is nothing but mole fraction of a compound.
Oh, okay.
Mole fraction of a compound is equal to number of moles of a compound divided by total number of moles. Again, I will repeat. Mole fraction of a
Okay.
compound is equal to number
Okay.
of moles of a compound divided by total number of moles. Okay. Next one,
Okay.
partial pressure of a compound is equal to,
Partial partial pressure.
yes, partial pressure of a compound is equal to mole fraction of a compound multiplied total pressure.
Total pressure. Okay.
Now let us see the question. 10,000 pounds of a gas mixture of methane and ethane and hydrogen is under 2000 psi gauge pressure. The mixture contains 10% methane and 5% hydrogen and remaining 85% as ethane. Calculate the partial pressure of each compound of this gas mixture. The atomic weight they have given. So first we need to identify how much pounds for methane, how much pound for hydrogen and how much pound for ethane.
Okay.
So see, 10% of 10,000 for methane, 5%
Okay.
of 10,000 is for hydrogen and remaining
Okay.
85% for ethane.
Okay.
You can do
Okay.
like this or you can do 85% multiply 10,000 will give the same value.
Okay.
Now we identify the mass of each compound. In
Okay.
order to identify the molecular weight, they have given the molecular weight of each atom. Based on the
Okay.
formula, we will identify
Mm,
the molecular weight of the compound.
okay.
Okay, I believe you know this how to do.
Okay. Yes.
Okay,
Carbon having the molecular weight to 12 and hydrogen having 1. There are 4 molecules. That means 4 into 1.
so hope you know this. After
Okay.
identifying the mass and molecular weight, we need to identify mole of each compound. What is mole? Mass
Okay.
by molecular weight.
That's molecular weight.
So mass by molecular weight of methane, mass by molecular weight of hydrogen, and similarly for ethane.
Okay. Okay.
Then identify total mole also.
Okay.
So after identifying the mole and total mole, you can identify the mole
Okay.
fraction.
Okay.
Okay.
Okay. Okay. Okay.
Mole fraction for each compound will be identified.
Okay.
And after identifying the mole fraction, just cross verify by adding all
Okay.
together, it should be equal to 1.
Okay.
This is for just a cross verification, whether we are
Okay.
proceeding rightly or not. Next,
Okay.
for partial pressure, we know
Okay.
mole fraction multiplied by total pressure.
Multiplied
Total
by.
pressure is
Okay.
given in the question.
Okay.
So
Given
we
here.
will
Okay.
identify the partial pressure of all the compounds individually.
But in the question, the pressure, partial pressure, which is given in the gauge pressure, then
Yeah, it's
we don't
okay.
want to convert it into atmospheric.
Yeah, it's not required.
Okay. Okay.
Based on the
Okay.
options, how they give.
Okay.
How?
Oh, okay.
This question, the root mean square pressure level from a sound source is zero point 0.2 Pascal. What is the
Mm.
decibel value of this sound? You can note down this formula because it will not be in our formula sheet.
Oh, okay.
Okay, basically this formula is used to convert Pascal to dB.
Okay. Okay.
So in the formula we can see micropascal, and in the
Okay.
question it is Pascal. So convert Pascal to
Okay.
micropascal. Just multiply 10
Okay.
to the power minus 6, you will end up with
Okay.
micropascal value.
Okay.
Okay. Then apply
Okay.
this value in place of RMS.
Okay.
Okay. Then do the math, you will end up with a decibel value.